Good morning, afternoon, or evening, depending on where you are in the world. And welcome to today's DevOps.com webinar, brought to you by TechStrong. My name is Cody J. Brown, and I will be moderating today's session. We have an exciting presentation ahead of us, but before we begin, I have just a few housekeeping notes. Today's event is being recorded, so if you miss any or all of the discussion, it will be made available for you to rewatch. You will receive an email after the webinar concludes with a link to access the on-demand. We want to hear from you throughout today's presentation, so please feel free to send in your questions at any time by using the Q&A tab. We will try to address as many as you can, so please send those questions in early. We also encourage discussion by using the chat tab. Let us know your thoughts, comments, concerns, suggestions, or just say a quick hello. Finally, at the end of today's webinar, we will have a drawing for 4 $25 Amazon gift cards. Stick around to see if you are one of our 4 lucky winners. Now let's go ahead and kick off today's webinar. Our topic is SAST Reimagined for the Developer. I'm joined today by Frank Fisher, Developer Advocate with Snyk, and Mick McCulley, Field Strategist with Snyk. At this time, I'm pleased to let Frank get us started. Thank you for joining us today.
Yeah, thank you very much for the introduction. Welcome. My name is Frank Fisher. I'm working in the product marketing for a product that is called Snyk Code. And as you will see in the next hour or so, it is a static analysis security testing, but with a twist on it. And it's something that reimagines SAST for the developer. I'm joined here by Mick McCulley. I will hand over to Mick to start us off. And then later on, I will take on the demo. So Mick, take it away.
Awesome. Thanks, Frank. So yes, I'm Mick McCulley. I'm a field strategist here at Snyk. So I get the pleasure of actually focusing on the Snyk Code product, which is, as Frank just talked about, our SAST solution. So I get the privilege of actually sharing some of the details of what we do, how we do it. But for today, I'm going to do a quick introduction to Snyk, and we'll spend the majority of the time showing you the product, showing you the interaction, showing you how users and individuals can take advantage of some of the information of how Snyk works. So to get things started, Frank, if you want to jump to the next slide, what I thought I would do is at least level set everybody just as a quick introduction to Snyk. Who are we? What do we do? If you're not familiar with us, this is a quick overview of our focus, looking at it from a Snyk perspective. And what I've got up here is a slide talking about modern applications. So if you look at any new cloud native modern application, many of them are made up of the elements that you see over in the far left, the code, the open source containers, infrastructure as code. From a Snyk perspective, we are a security company. We help organizations understand risk. However, we've got a unique aspect to what we do in that we build solutions specifically for developers. Developers are our first thought in everything that we do, and that the solution is actually geared towards. So when you look at those elements, what our focus is to say, how can we help you identify any of the security risk in those different elements and provide guidance on solving it? And so that's our number one goal, is how can we help you with that? And if you look at those elements, basically what it boils down to is anything that makes its way into a source code repository, we want to tell you if there's risk associated with it and what you need to do to remediate that risk. And looking at it from a very high level perspective, and Frank, if you want to build this out, it basically boils down to this. It's the code you write. When you look at open source, it's the code somebody else wrote. When you look at containers, it's the code that defines the operating system with Docker files or the containers. And then ultimately, if you look at infrastructure as code, it's basically the code you write that defines your cloud infrastructure. So our focus is to say all of this code that's being written or used, what is the risk associated with it? How do you identify it? All of them have unique ways to actually discover vulnerabilities, but they also have unique ways to solve them. Our focus is that. Today, we're going to focus on that top level. The code that you write. This is the Snyk Code product, the SAST, Static Application Security Testing. So to get things started, I think what the first thing to do is to define the problem, the struggle. So Frank, if you could jump to the next slide, please. This is Snyk Code. And so what we did was take a step back and say, all right, the SAST idea, the SAST capability, static application security testing, it's not anything new. Organizations have been using this for years, right? It's been utilized by many organizations to help identify and understand potential risks inside of applications as early as possible. However, there have been challenges with it. It's had a lot of different details and elements that's hindered it from being virally adopted by everybody writing code. And what this is it starts to get into some of the details of what those challenges are. And on the left is actually, it's a white paper. It's readily accessible. This particular white paper actually spent some time researching what's kept SaaS solutions from being virally adopted by developers. What are those reasons? What's the elements that hinder that adoption capability? And the themes that came out of that are what you're seeing over in the right. So those are basically categorized into these different buckets of being able to work within a developer workflow. And this has several different meanings of not only within the environment developers work in every day, whether that's source code repositories, IDEs, or even command lines, but it's also within the time frame. Most agile modern applications are being developed at a very, very rapid pace. And I talk to organizations that do deployments sometimes to production every few minutes. Being able to adapt and stay on top of that is critical, and being able to understand what your security posture is at the same time becomes very difficult. Accuracy, the one in the middle, is probably one of the more prominent ones. Accuracy is something that SAST historically has struggled with for years. I stole this term from another webinar where I heard somebody coin the term false positive as a service. And that basically summarizes what SaaS solutions have been thought of, right? It's the fact that they inundate you with so much noise, it makes it difficult to find the real issue that you should focus on and fix. The last element to this is it shouldn't be just a security issue, right? It shouldn't just be, here's your list of problems. You should be able to provide some detailed guidance on how do you fix it. Once you find something, what is that process for actually remediating it? In the white paper, there was a developer specifically that mentioned, if you've got a solution that's smart enough to go identify all of the problems in my code, why isn't it smart enough to tell me what to do about it? So these were the items that we had in focus when we set out to solve this problem from a Snyk Code perspective. So there's a couple interesting elements associated with it and things that we consider unique. So Frank, if you could go to the next slide, please. And what I wanted to do is take a quick sort of jog from a history perspective, and we truly believe that we're onto something new and different, and by definition, a disruptive innovation. The interesting aspect to me, and what I shared up here, is a couple examples throughout history where some of these disruptive innovations are perfect examples of how slight changes, tweaks into the approach had significant impact on the way things were used or consumed or the design. If you look at early versions, the penny farthing versus the bicycle, right? A slight adaptation of, instead of being direct drive on the main wheel, using a set of pedals and a gear, completely changed that design and the adoption of the ability to actually use and consume the bicycle in a very easy to use fashion. Telegraph versus telephone, right? Electronic pulses versus actually hearing somebody, and the adoption of it changed significantly. Saw the same transition as you start to look at other additional technologies from, what was historical mainframe computers to people having this concept of idea was, what if I had my own computer that I could use and consume? Slight changes in just the approach had significant impact. And this is where I want to spend just a little bit of time at discussing those. And then I'll turn the reins over to Frank to actually show you a live fire example. So Frank, next slide, please. So a little insight. We'll use the rest of this webinar more of a, from a show and tell perspective, more of a show than a tell. There's a lot of detail and insight in just these 3 bullet items. I love sharing those details. And if it's of interest, we can definitely go into these details more one-on-one with any of you that are interested. When you look at what is that disruptive innovation about what we're doing inside of Snyk Code, it boils down to these 3 core concepts. The very first one is speed. There's some new technology that we're leveraging on the SAST side that allows us to perform this analysis in a very, very fast method. It's approaches to how we do the code modeling, some of the technology underneath the covers that's actually leveraging new approaches in order to achieve that. And so we're talking about speed differences that are going from, in some cases, days and weeks down to minutes and seconds. This is core in order to be part of that agile process and give that feedback in a time frame that's actually consumable. That's the first one, right? Ability to actually use it within the context of the decisions when you're actually writing the code. Next one's accuracy. This is the one, as I mentioned before, was one of the more prominent ones from a SaaS perspective of saying, do I have confidence in the results? Is the information that's coming back to me something that I care about and should leverage? We're leveraging some new crowd wisdom, supervised machine learning approach to actually learn from open source code. There's this huge abundance of open source code that's out there. Why not leverage the information knowledge that's inherent inside of it in order to make these solutions better? This is by far one of the most unique approaches to what Snyk Code is doing to ensure that the results that we deliver back to our users are as accurate as possible. The last one, and all of these are examples that we'll go through in the session when Frank shows you this live, is actionability. This is in Snyk's DNA. Our approach isn't just to give you a laundry list of here's everything that's wrong. Our focus is to help organizations actually address this risk, help developers identify issues and fix them before they ever make it, potentially even to the source code repository, but definitely before they get to production. Actionability is that most important element. How do you actually go about remediating these issues? This is also where we put a strong focus on how do we capture and provide that guidance that's most relevant to developers in the language of developers that gives them examples of what to do when they encounter these vulnerabilities. And this is information, again, that we can leverage some of this knowledge base that's in this open source community and the crowd knowledge that's out here to say, here's a vulnerability we found in your code. By the way, your peers had this exact same example. Here's what they did to solve that, maybe using the exact same language, and in some cases using the exact same framework to help provide guidance associated with that. That's Snyk Code at a very high level. There's a lot of additional detail in here, but like I said, we wanted to spend the majority of the time actually giving you some insight into how you can consume what we're delivering in the back end in a day-to-day activity. So with that, I'm going to turn the reins over to Frank to give you some examples of what does this look like? How does Snyk actually work? What is this disruptive approach and how does it change your interaction on a day-to-day basis?
Yeah, thank you, Mick. Yeah, so the next, so say block, and I think the majority of time we will spend here is actually a demo. And we will play a bit of a story here. We will make, or how should I say, we will live through the life of a pull request in this regard. And I hope it has all of the different aspects of a developer life being touched upon. I'm pretty sure about this. So what are we going to show you? What you can see here is a kind of high-level printout of the software development lifecycle. You normally have an IDE involved. You start to have pull requests. You have a web interface here that you can use your Git repository scans with and stuff like this. And you have your CI/CD pipeline at the end of it that normally builds the solution and deploys it then. And static code analysis literally lives up here. As Mick already said, normally because of the enormous runtimes, it lives more here in the CI/CD pipeline than it does in the IDE because, who can wait for hours until you have the results? And this is something we want to change. So what I will show you is all of these, IDE, PR, web, CLI. I will show you all of these. And I have a little story in my mind that I would like to tell you with. Okay. So my story is we are talking about car sharing telemetry. So now we are a developer and we have a ticket that is asking us to expose some telemetry data of car sharing vehicles through a RESTful API through the web, so that an external service can consume them. This is our task that we have. Okay, so with this, we are leaving the slides and going into the demo. So first off, we have here our Jira. And as you can see, it's a demo, so I kept it simple to show the things that are important. And you see, we have our ticket here, the one ticket, yeah, make an API interface for the vehicle telemetry. So first question that I asked myself was, do I need to do everything myself? Is there something that I can make use of? And I actually found there is a library already in our company in use. And the library is a DB interface, and it has a vehicle DB JavaScript interface made for it. And if I look at the manual text, it seems to have, get vehicle list and get vehicle details. So it seems to have all of the things I need as a developer. Okay, so there's a library. I don't need to reinvent the wheel. I can use this library, and this library is typical in such kind of projects. The person who wrote this library, I don't actually know who did it, maybe even left the company years ago, but everybody is now using this library, and it makes sense, because it's easy to interface and it's nice to have. By the way, I'm using JavaScript here. I'm using a Node.js infrastructure based on Express is the web server that we will use. So we have this already here. I did a kind of a look on it. So what I did was I already included this project here in our interface of Snyk. So this is the Snyk UI. You see, I have this project already included. And if I look at it, there are already some things a bit fishy, that is related to this library. And this is also a typical situation. You have these libraries, they are not really maintained. There is problems. So one of the typical use cases that you would have as a developer is have a backlog of technical debt and start working through this technical debt. And what you can see here is create Jira issue. So what I could do by clicking here is literally saying, I'm using my Jira a project that I just showed you, and I can say, hey, I'm reporting a bug here. And I say, yeah, well, there are not a lot of users, so it's taking me, and the assignee also me. And then I can fill in, the details here, and I can literally, by using this, I can create a Jira ticket right away. So I don't need to kind of copy paste or something like this. It's fully integrated in this regard. So makes sense. Could help me with the technical debt. Could help me with building the backlog and keeping that in check. Another thing that is quite interesting for me as a developer is this score here. There is a priority score given. And the idea with the priority score is there are several values going into the calculation of the priority score. And as you can see, it argues why it has the 600 here, found in a file appearing in multiple code flows. Okay, so this is a library and it's used by several others. And since this is heavily used, it's obviously more important to be solved. And has fixed examples available. This means this is actually one problem that is easier to fix, because we give some more advice. We give some examples on how other people in the open source community actually solve this problem. Okay, so now we have our Jira here. I showed you the web UI a bit. We will come back to that later. And by the way, this is a GitHub project. Yep.
Real quick, if our friends joining us today were developers and they had a source code repository, and let's say they went to snyk.io and signed up for a free account, what you just showed them, how would they get to that point?
That's a good question. So if you so say log in, it will show you this view. And you can see here, add project. And on the one side, I, so to say, integrated GitHub support. into that. So I can literally, if I click on it, I will see my GitHub projects. There are tons of them. And I can simply click and say add selected project. What I found really nice, and I use it quite heftily, is you can also say add project and public a GitHub repo and public one. Monitor public one. So when you have the URL of the GitHub repo, you can literally monitor public one. It will show you the results from the public one without even having your own source code in there. Okay, so this is very helpful. It's very instructive. Sometimes it's quite nice to scan open source projects that you are relying on and stuff like this. So this is the way of getting into it. Okay, so back to my story. So what we have now is I started coding. Okay, so here is my index. JavaScript, and I keep it simple, okay, so that everybody kind of can follow what we are doing here. So first of all is we have this test JavaScript here. So the infrastructure, actually the library gives me a test interface that will, so to say, give me valid data back without carrying the database, and it's easy to test for me. So I'm using this now for now, and I have two additional functions, two get functions here, and the one is the vehicle list, and the one is the vehicle, and I can, so to say, ask for details on the vehicle. So let's have a look how this looks. So we are saying node, and we are starting it. So now the service is listening, and we're taking another window. And I prepared this here so that you don't have to watch me typing. So you see, it answers back, giving a simple JSON file, you know, RESTful and stuff, and says, yeah, we have these vehicles here. And I can now go deeper and simply say, okay, I want to have the details of the vehicle this way. So, and it gives some more details about it. You know, there's a license plate, the mileage, the unit, and stuff like this. So this is the way that this service should behave, and this is what we expect. Okay, so now stop it again. And now we can literally say, okay, seems to be good. Yeah, we did our tests here, and we're still local. You know, nothing has happened now to the source code management from now. I didn't push it or something like this. It's still locally here on my machine. Okay. The first thing that I want to do now is I would like to have a look from a security perspective. So what I do is I have the Snyk plugin here. This is a WebStorm, as you can see from the logo, and we have a Snyk plugin. And what I can do is by pressing here, I actually start the scan. There's open source built in here. So as Mick just showed, we have our partner product open source that is also that would scan now the dependencies and stuff like this. As we are talking about Snyk Code today, I don't have any things to show here on the open source side. And as you can see, the results are already there. So what happened is that my project here, local project, was packaged. It was sent to the server. It was scanned, and the results already came back and are shown here. And as you can see here, the vehicle DB JS, these are our hard-coded credentials, the ones that we already found. So this is nothing new. But here is my index JavaScript, and it has a bug here. It says cross-site scripting is possible with my code here. Okay, so let's have a look. It's a high severity bug. It's CWE 79. If I click on this, I get to the deeper information about the CWE that we have here, number 79. And it says unsanitized inputs from data from a remote source flows into send, where it is used to render an HTML page returned to the user. This may result in cross-site scripting attacks. So what it does is it really argues why it thinks that this is actually a problem, and here we have something to fix. It also uses, into send. And this is actually the name of the function that we actually have. What I could do now is I can click through this. So it starts off on the vehicle DB, goes there and comes back to index. And then flows into this thing. So what we have here is, number one, multi-file. So it starts on other side of the fence and comes back into my file here, and obviously it's right in this, because what I'm doing here is I'm simply getting stuff from a database. It is read from the database, and the database is an external data source, and in security, you should not trust any external data sources, even databases. You should not trust them. And the problem here is that it gives it back, and the client on the other side perceives this as an HTML page. Yeah, because the client could be a browser, for example, sees this, and there's nothing indicating to the browser that this is actually not HTML. Okay, so I need to make sure that the browser understands that this is actually not HTML, it is JSON that I give back. So I can do this by setting the header and saying, okay, content type, application JSON. So next question, does this solve my problem? So I simply start another scan. You see, this is now a bit grayish because it says obsolete. And the idea behind it is it tracked, there was a change. I did a change now, and the result here was no longer current to what the source code was. So I did a new scan, and the scan is there. And you see, hey, my cross-site scripting is gone. Yeah, so I did the right thing. So with this, my client now knows, okay, this is JSON. Don't try to interpret it as HTML. But what I see here is new. I have a quality issue. Yeah, and the quality issue says the content type application JSON that I just set here does not specify a jar set. And this is a bit sloppy for me, and I have to admit it is sloppy. Yeah, I should set the jar set. So what I do is I simply add this here and save it again. And let's see, did it fix the problem? Do we have no code quality problem anymore? And so what you see, it's again obsolete here, and you see, code quality gone. Okay, I did the right thing. So I set the jar set, and my quality is okay. What you see is obviously we have the same problem down here because we're using the same thing, but there is something more. It's a SQL injection. And what I want to make you aware of is this is super hard to find for me as a normal developer. Why? The SQL injection, if I look at my code, okay, if I look at my code, I'm using this vehicle DB. I'm calling the function get vehicle details, okay, and I just piping some parameters that I get into this function. And in a way, this is not, it's not forbidden, it's not something that in itself is very security relevant in this regard. I could imagine that, for example, the SQL string behind this actually says, hey, there's a parameter coming in, dear SQL database, this is a parameter, don't interpret it as a command or something like this. And with this, we are pretty good. We are okay with this. I could rely on my library to sanitize what comes in before they making a query, So in a lot of incidents, a lot of occasions, as a developer, I will simply call this library. I will not look deeper into this library because, hey, it's there, it's used by everyone. So why should I care? It's like everyone is using it, so I do anyways, But what happens by me using this library in this way, and the library having this kind of look to it, and as you can see, it constructs the query by using the license that is given over, and obviously this is a SQL injection, but in itself, it's not a SQL injection if you separate the two functions from each other. Only when you combine the two functions, then it gets a SQL injection. So two things I want to mention here. So the one thing is, as a developer, as I mentioned, super hard to find. And why is it super hard to find? Because it's multi-file, it is in a library, dig down somewhere, I don't look at it. The next thing is typical static analysis solutions do a delta scan. So what they try to do is they try to save time by having a subset of the rules used, and by not using all of the files, but rather using the files that you changed. And scanning these files. If you would scan the file only, you will never find the SQL injection. So you need to do an interfile scan. You need to use all of the rule sets. And this is actually what we're doing. So we don't have different rule sets and we don't have different engines. And we do scan all of the files in the beginning, in the IDE, and we still are fast enough that you literally can do this while you're coding. It's the same engine, it's the same rule set throughout the whole software development lifecycle. And this is something that I think personally, I really like this idea behind that. Okay, good. So I leave these in there simply to have to show something later on. Okay, so I don't correct them by now. I just leave them in there. And this is also addressing one of the things that we get asked quite frequently. And one of the questions that we get is, what if a developer maliciously tries to make a pull request with malicious code? Can we sort of say catch the developer down in the pipeline with the SDLC going on somewhere deeper in the pipeline? Can we catch this developer? And yes, you can, and I will show you how this works. Okay, so we have this. I'm doing the commit now. I say check for the first issues, but we still have the SQL injection, and maybe we need some larger attentions. And we're making a pull request out of this. And I need to comment. And we are saying pull request. So what is now happening is, obviously, my IDE is transporting the source code to the source code management system, and I just did a pull request. So I said, hey, I want to merge the two, the existing source code with the source code I did in this change here. As of now, everything was local. Nothing hit the source code management system by now. So I can literally work on my infrastructure here, do my scans, do my changes and stuff like this, without having the local infrastructure or the scanning infrastructure then, so to say, being kicked in by using the source code management system. That was my thing here as a developer. Now I'm getting official, so to say. Now it's in the pull request. So okay, let's see. We're going here. We're loading this, and you see there's a pull request now. So we are going into it. There's my pull request. I named it comment, and you see, ooh, it failed. So Snyk, Snyk Code kind of said there are two SAST issues that were found. If we're getting in the details, you're seeing there's a SQL injection and there's a cross-site scripting. And what happens here is you don't see the hard-coded secrets anymore. So what we are doing here is we're literally focusing on the things that the developer did differently. Not what happens already, what is kind of in the mix already there. It is now focusing on the elements that I just checked in, and just these deltas are seen as for the scan. You can see, we have the commits, we have the test type is SAST, and I can dig a bit deeper into what kind of issues do we have. And you see, this is the view that I would have as a code reviewer, for example. I can literally, as we had it before, I can jump in the file. It shows me the data flow that I have. And I can go to the fix analysis. And in the fix analysis, it gives me more information. What is a SQL injection? How to normally prevent the SQL injection, and also some example fixes of projects in the same, so to say, realm, in the same context that I was using, the same backend mechanisms and stuff like this, giving me an idea how to fix it and how to move on with this. So the idea that we have here is this is directly integrated into the PR check that I have, and you can see we're already breaking it, and we are already giving information back to the code reviewer and saying, hey, you should be aware that there's something happening here.
Frank,
okay, yes.
Real quick question: if you were looking at those fix recommendations, and you thought they were intriguing. Yes. Is there the ability to delve into some of those details in those open source examples a little further?
What do you mean by looking at them?
The link that happens to be at the top of those, being able to actually go into those.
Yeah, okay. Yeah, if you click on them, you actually see them side by side. So you have a deeper, so to say, a listing, a deeper understanding. What was the origin of the problem and how was the problem solved? This was what you were asking for, right?
Exactly.
Exactly. Good. So what I showed you now was we started with the IDE. We went into the PR request. We got the PR request being decorated. So we get into the web UI and have the chance to review the code and stuff like this. And the last thing, obviously, that we need to do is we need to integrate it in our CI/CD pipeline. And to do this, I have a little server here in the background. This one. And as you can see, it's a Jenkins server. The normal Jenkins installation that you have. I use a Docker container here, and I'm running Jenkins on this Docker container. And what I did was I didn't use the Snyk plugin for Jenkins. So there is a ready plugin that you can use. It actually has some nice features like keeping the engine updated and stuff like this, but I didn't use it. And the reason why I didn't use it is I want to show you how simple it is to set this up. So there are two things you have to do. So the one thing is you have to define, this is my Git repository. Okay, so obviously this is the link to my GitHub project. And the next is this. What I do literally is I call the CLI, and obviously our plugin would make it a bit easier and you would simply click it away and then you have the call. So what I do here is I call our CLI plugin. I say, this is the call to CLI. I say, I want to do a code. I want to test, and I want to test the local directory. So this is all that you need to do to kind of set this up accordingly. And we can sort of say run a build and see what the console output is in this regard. And what is now happening is the same that we already had in the IDE. So the CLI is taking this code, wrapping it, sending it to the server, getting the scan, getting the result back, and reacting accordingly. And as you can see, the build failed, because we have our problems here. There's a SQL injection and stuff like this, and the CLI will come back with an error code in this regard. So our CI/CD pipeline failed. So what I wanted to show you was like all of this. One after the other. So we had the IDE, we did some coding, we did several scans in here. I haven't counted how much, but we did several scans. I showed you we did a PR request. Then our PR request was kind of, so to say, decorated. It's with a comment and saying, hey, there's a fail that we have. Then we were using the web front end to do the code review, but also to look at the project itself. And the last but not least, we did the CLI part of it. So all of this we did within, I don't know, like 20 minutes or so. So what I showed you was I was using WebStorm. Obviously, there is a lot left and right to WebStorm. So you can also use PyCharm, IntelliJ, RubyMine, and stuff like this. I showed you using GitHub, but we are also supporting, obviously, GitLab and Bitbucket Cloud and Azure Repos, From the SDLC side, I was using, I showed you Jira, the Jira integration. I showed you the PR scanning capability that we have, and I showed you using the CLI. In this perspective, I used it in Jenkins. I use JavaScript, but obviously, there are more languages that we support, and the languages can be mixed within the projects. So if it picks out the right kind of input filter for the right language in this regard. And last but not least, I took Node and Express framework, and you saw like this is supported. We have a massive support of different libraries, depending on what kind of language you're using and stuff like this. So obviously there's much more to see here. So this was my demo, and I want to go into summary. So number one, if you have questions, please pipe them in, so let them rain on us, and we try to answer. If you have a suggestion how to improve my demo, please do so. It was the first time I did it, so there's always space for making things better. I'm, to be honest, a bit astonished to be so fast, because I thought my demo would take at least 5 minutes longer. But hey, the scans were coming back so fast, so I had no time in between the scans. Perfect. So the point that what we wanted to show you was, as a developer, and I had the developer head off now, the developer head on my head now. As a developer working with SAST, with Snyk Code, is something that feels very natural. It's embedded in my workflow. It's working in my IDE. It is very fast. I can click scan and I will get the results in seconds. And I can work with these results. The IDE, it's arguing why the problem exists. It uses elements of my code. I can jump within my code in the data flow diagram. So it's very natural for me to use that. It's integrated in my PR requests. So in this regard, it automatically helps me as a code reviewer, for example, to have a scan on it and to see how this reacts. And it's integratable in the SDLC, so I can literally automate it and have it running every time I do a deploy, or I try to do a deploy if I don't have malicious code in there. So for us, SAST no longer needs to be this kind of a complex and clumsy and slow and a typical security thing that the developer kind of hates. For us, this is something new. We are breaking the rules here, and we are looking at the developer to be developer friendly as a tool and to be part of the workflow. We embed ourselves into that. And with this, what we are also doing is we are changing the role of SAST. So as of now, SAST is very, very often originated in the security team and used as something to produce reports to show developers how bad things are. None of the faults in the reports, none of the issues are actually addressed with this. It's just like a little blame game, so to say. Our idea is make it actionable, make it an active part to improve your organization's security posture by literally addressing it the most shift left you can, so the developer does it in the IDE, and by being actionable and by being embedded in the workflow, you can actually use it as a developer, and you have seen it's easy to integrate, it's easy to understand, it's actionable in that regard. Good, that was me. So Mick, questions? Do we have questions?
I've got an interesting question for you, Frank. There seems to be one pretty prominent term that gets thrown around when you start talking about SAST. However, you seem to have omitted it from any of your examples as we were walking through, which is false positives. I know this was a small example, but how many did you encounter in any of the scans that you just ran through?
Okay, so the generic answer would be there is no static code analysis. It's impossible to have a static code analysis without having false positives. That said, there are many ways of reducing the false positives. So why is it so important to remove the false positives? Maybe a good question to start with. As a developer, if you hand me 5,000 issues and I start to take the first one, and the typical rate of false positives might be around 50%. It's not unseen that you have half of all the issues found are actually false positives. So for me as a developer, this means I don't like the whole thing to start with. I take a deep breath. I take my first issue from the stack that you've given me. I work my way through it. It takes me 10 minutes to understand what is happening here, and then to find out actually it's a false positive. And then I do the next one and the next one, and it turns out that 50% are actually false positives. You could imagine what this does with my motivation. You could imagine that it, literally after 10, I'm quitting, kind of. So this is the problem with the false positives. This is the chief complaint that developers have on how these tools are actually producing results. On the flip side, what we see is a lot of people are benchmarking these tools by simply looking at the numbers. Okay, so you're running a scan, and the scan gives you 5,000 issues feedback, and the other scan from another tool gives you 500. So, oh, that tool with 500 needs to be bad. That is very easy, and you are neglecting the idea that probably from the 5,000, 2,500 are actually false positives and not really worth the effort. So what are we doing from a Snyk Code perspective? Snyk Code, as you can see, is very, very fast. So we can use this fastness to our advantage. So what we are doing is we're using per language 150,000, some languages we're using 250,000 open source repositories. And we are scanning these open source repositories. We are talking about billions of lines of code. And this is our input data that we are using into a machine learning human-guided approach. So what we have is we have a security engineer and we have the machine learning part of it. And these both are mining the data that we have in this open source repositories. The idea that we have with this is that we gain a lot of insight. We can learn literally from the knowledge of the global developer community. So whenever they had a problem and they fixed the problem, we kind of see this and we can use this to our advantage to tweak the machine accordingly, to reduce the false positives that the machine is reporting back, to add things, true positives, that we would like to see. The machine doesn't come up with in the first iteration, so we have to do another iteration and we get it then. By the way, Snyk open source is helping us enormously with this by knowing what kind of issues were in the history of open source repositories. We actually pinpoint what we'd like to see. So we know where the true positives are and we can check for these true positives in our result files. So this is an iterative process. So the machine learns by itself and it's guided by the engineer. This has two effects. So effect number one is we are extremely fast in getting new knowledge bases set up. So if you look at our roadmap, we're literally adding a new language every month. I think that is unheard of from any other tool that you can see out there. This is done by having this kind of an infrastructure, by having machine learning as part of it. The next thing that we can do is we can increase the accuracy exponentially, because we are not only looking at a few benchmarks and artificial code repositories to see if our rules are according. We are looking literally at 120,000 real open source repositories, which is also unheard of in the industry. And with the combination of this, we are able to suppress our false positive rate to extreme lows. And I think you mentioned in the beginning accuracy. This is how we do our accuracy. This is how we so to say approach the accuracy in our field. Okay, that was a lengthy explanation, but I think sorry, you got me.
It was a good answer. No, and that was some of the information I was alluding to at the beginning, that we love sharing these details with anybody that's interested. So there's a lot of unique elements that happen underneath what we walk through today. So Frank spent a lot of time today illustrating that consumption of Snyk, right? How would you use it? What are some of those details in there? Our focus also is, what are we doing that's unique that allows that to happen in the first place, right? Like everything Frank did was because of what we've built in the background. So I think there's a couple of questions in here.
Deduplication, or maybe you should follow on a code quality scale. I think a site from a new acquired company was getting with a well number of vulnerabilities. Okay, I'm trying to. Okay, deduplication. Yeah. Okay, so there are. I hope I get the question correct. The idea with the deduplication might be that you are saying, for example, my library function that I was using now has a SQL injection because I was using it in a way, and all of a sudden the combination of two became a SQL injection. The same could be true for somebody else in a different part of the application, using the same library, using in the same way that I did, and also having the SQL injection. So the opportunity that you have is to literally look at this library, fix the library, and with this you would have both of them, both of the problems going away. So I guess this is the basic idea of the question. And as you have seen in the beginning when I showed the priority score, one of the reasons why the priority score was pointing to this file was that it said, hey, this file is actually used by a lot of different parts of the application. And this is the reason why we push it higher, because it gives you the chance to kind of remedy this problem by addressing it with this file only. So this is the first part of the answer. The second part of the answer is, from a security perspective, sometimes you want to have these duplications. So I would not want to have suppressed the idea that when we have the SQL injection already here, we don't report it anymore there because, you know, he is already in the reporting. No, it's both ways result in a SQL injection. So we need to have both reports. But with the priority score, we are pushing actually the fixes higher that, so to say, are used by several ways in your application, going through the same file and helping you to kind of remedy once and hit several bugs with it, if this makes sense. I hope that I got the kind of explanation correct in this regard.
Got it.
So yep.
Another quick question asking about whether or not Snyk integrates with global risk and compliance platforms, and in cases where the risk is something that you accept, that is also shared with those solutions. So a great question. There are ways. So one of the things, and again, this is more of a holistic sort of Snyk answer, is we have a lot of details and information about risks we discover, whether it's in the containers, in the Docker files, in the infrastructure as code, your open source, or the code that you write, Snyk Code, what we just focused on here. All of those results, we do have some built integrations with some other vulnerability management systems, but that data can also be fed just as easily into some GRC type of solutions as well. We understand that typically we're a piece of an overall risk platform within an organization. My background is in very broad security, anything from network to data level to application security. So there is obviously the knowledge that we're a component of that. So being able to share that information. So we do can share it. We actually have customers that have integrated in those to make sure that they're rolling up for full visibility perspective.
And another part of this is also this kind of scanning, right? When you want to say, I want to have this in here, but I'm okay with excluding the other thing, right? So what I can show you here is...
and there's another quick question while you pull it up, Frank, which is just a fast question on languages. which languages are supported. So I'm going to start, and you tell me if I miss one. So there's Java, JavaScript, TypeScript, Python, C#, Go, Ruby, PHP, all currently supported. Near-term plans include Kotlin, Swift, and C++ by the end of the year. So hopefully that helped. It's also shared on our website. But again, reach out to us and we can obviously share, especially if there's language requirements outside of those. We also love soliciting what's important to individuals that are programming today, because that's how we prioritize our languages.
Yep. So ignore button. As you can see, we have here the web UI, and you can have this ignore here. And if you press it, you can give explanation, because it's you perceive it as a false positive. You ignore it temporarily because you say, okay, we have this in the backlog and we will address it, or you ignore it permanently because you don't want to see it again. If you ignore it temporarily, you can say how many days you want to have it. If you do forever, obviously it's forever. And we advise you to give a kind of a comment why you did this to your colleagues, in telling them, because we have it on the backlog or something like this. Over commenting is always better than afterwards puzzling why happened this and what was going on. There's one thing that is quite interesting with this one here, the way it is working. Because the majority of systems out there, they take the source code. They take 5 lines above and 5 lines below, and they make a hash about it. It's a bit of a loose hash, so it's not very sensitive to changes in the text, but it's a hash. And they are simply saying, okay, we are ignoring anything that comes up and that has this hash, so we are ignoring it, okay? So what happens if you are not changing the logic, but you are adding comment lines, or you are changing the name of a variable or something like this? Yeah, for the system, this is actually no longer the thing you ignored. It's now something new, because the hash changed dramatically, and we are now seeing it as something new. This is different than what we do. We are looking literally at the intermediate representation to make this hash. And the idea that we have with this is, as long as you not change the logic, you can change everything else. You can change the name of the variables. You can have comments in there, whatever you like, whatever you please. As long as you're not changing the logic, we will understand that this is the same issue. And this issue needs to be, in my perspective here, ignored, because I just say ignore it. Only if you change the logic, we are no longer seeing this as the same bug, and we are then reporting it as a new bug eventually, if the bug is still in your new logic, if this makes sense. So it's very smart in this regard. It's very it's not as sensitive to changes in the code that is literally syntactical and not any kind of semantic.
One last, because I know we're right up against the time, and we want to turn the reins back over to Cody. There's one last question about false positives. If they appear many times, will you push them to higher priority? How do you prevent the case? So the quick and easy answer is any false positives ever seen in our results, we actually actively ask to share them with us, because we will change and adapt the rules so that you don't see those. The ignore button is more the exception, where maybe it's a real issue, but you're willing to accept that risk. And this is some of the data that we talked about that could be fed into a global risk and compliance platform, that you're aware of a risk that's been accepted. False positives, however, are not as tolerable to us. So if it's something that you're seeing, if you're seeing it often, we want to be aware to make sure that they don't occur. And so those shouldn't be popping up. So that's a very, very brief answer. We can definitely delve into more details, but I know Cody, for the drawing, you wanted to share some of those details. So I'll turn the reins back over to you.
All right. Thank you for that.
Thank you.
So our 4 winners today are Percy R. So Percy R, congratulations on the first of our 4 $25 Amazon gift cards. Our second winner is Mike L. Mike L. Our third winner is Adrian M. Adrian M. And finally, we have Upinder T. Upinder T is the winner of our 4th gift card. So Frank, Mick, thank you so much for being here. Is there anything that you'd like to say to the audience before we actually do close out today? Any last moment thoughts?
Appreciate the time. We're excited to share this with you. If anybody's interested, obviously reach out to Snyk. You can also download and run the solution for yourself at snyk.io. We encourage people to actually try it out and appreciate it.
Yeah, go and try it out today. It's free, easy to sign up. Yes.
Awesome. Thank you both. Quick reminder that today's session was recorded. So if you missed any or all of the presentation, or you just like to rewatch it, it will be made available. Following the webinar, you will receive an email with a link to access the recording on demand. You can also find the recording on the DevOps website. Just visit devops.com/webinars and look in the on-demand section. It will be waiting for you. Frank and Mick, again, thank you so much for taking the time to put together this program. And I'd also like to thank our audience for being with us today for the entirety of the presentation. This is Cody J. Brown signing off. Have a great day, everybody.